Assalamu alaikum wa rahmatullah. In this video we are going to start with chapter 8, which is about Newton's laws. Let's start by part 1 of this lesson. At the end of this chapter you will be able to determine the components of a force in a plane, identify external and internal forces, state and apply Newton's third law on two interacting objects, state and apply Newton's first law on a system, state and apply Newton's second law to the motion of a particle in two dimensions, and derive the equations of motion of a freely falling object. In this part, only the first two objectives are going to be covered. Mechanics has two branches, kinematics and dynamics. We have studied kinematics in the previous lesson, where the motion is described using position vector, velocity, and acceleration, regardless of the causes of this motion. In chapter 8, we are going to study dynamics, where we describe the motion of a moving object and its causes. In other words, we are going to study forces. Now let's remember the main ideas about forces. A force is a mechanical action exerted by a body on another one. The effects of a force are setting a body in motion, stopping the motion of a body, changing the direction of motion of a body, and deforming a body. The characteristics of a force are point of application, direction, magnitude in a Newton. The types of forces are forces acting from a distance, for example, weight, electric force, and magnetic force, and the contact forces, for example, friction force, reaction of support or normal, muscular force, or tension of a string. When dealing with vectors in math, we know that any vector can be projected along the x and y axes. That means any vector has two components, the x component, which is parallel or confounded with the x-axis, and the y component, which is parallel or confounded with the y-axis. To find these components, we use the angles that this vector makes with the axes. How? Consider a vector u making an angle alpha with the x-axis. Ux is the side adjacent to the angle alpha. Then ux is equal to u cosine alpha. Uy is the side opposite to alpha. Then uy is equal to u sine alpha. Vector u also makes an angle beta with the y-axis. We can also use this angle to find the components of this vector. Ux is the side opposite to beta. Then ux is equal to u sine beta, and uy is the side adjacent to beta. Then uy is equal to u cosine beta. The same issue is applied on forces in physics. Any force has two components, Fx and Fy. Let us now learn how to find these components. It is very important to know that the components of F are the same wherever F is in any quadrant, because it has the same line of action, the same direction, and the same magnitude. In the right triangle formed by Fx and Fy and F, alpha is the angle adjacent to Fx. Using the cosine rule in the right triangle, we find that Fx is equal to F cosine alpha. Fy is the side opposite to alpha, and using the sine rule, we find that Fy is equal to F sine alpha. The components of F are independent of the position of its point of application or origin. Now let's solve the following examples. In example number 1, the force F1 is parallel to the x-axis and having the same positive direction of the x-axis. Then alpha is equal to 0. When substituting 0 in the expression of F, we find that F1 is equal to 3i. Notice here that we have used the scale 1 cm corresponds for 1 in Newton. In example number 2, the force is parallel to the x-axis but of opposite direction. Then F2 makes an angle alpha which is equal to pi with the x-axis. When substituting pi in the expression, we find that F2 is equal to minus 4i. In physics, it is enough to say that it is opposite direction to the x-axis, then it is minus 4i. F3 now is parallel to the y-axis and having the same positive direction. Then alpha is equal to pi over 2. By substitution, we find that F3 is equal to 2j. In example number 4, F4 is opposite to the y-axis. Then alpha is equal to minus pi over 2, and by substitution we find that F4 is equal to minus j. Again, in physics we can say that F4 is opposite to the y-axis, then it is simply minus j. In example number 5, alpha is equal to pi minus alpha prime. Notice that in this case, f5x is directed negative with respect to the x-axis. We say here that cosine alpha prime is equal to absolute f5x divided by f5. To find the algebraic value of fx, we say that it is equal to minus f5x cosine alpha prime. Directly, without thinking of the obtuse angle, we take the acute angle. In example number 5, alpha is equal to pi minus alpha prime. In this case, f5x is directed negatively with respect to the x-axis. So, cosine alpha prime is equal to absolute f5x divided by f5. Now to find the algebraic value of f5x, we say that it is equal to minus 5 cosine alpha prime. Why? Because its direction is opposite to the positive direction of the x-axis. That means directly, without thinking of the obtuse angle, we take the acute angle respecting the sign of the projection. Therefore, f5 is equal to minus 2i plus 3j. How do we apply this projection in physics? Let's solve application number 1 to explain it more. Ali is pulling a chariot by applying a force F, making an angle beta is equal to 50 degrees with the horizontal plane. During its motion, the chariot of mass 15 kilograms is under the action of its weight mg, a friction force F of magnitude 20 Newton, a normal force N of magnitude 150 Newton, and a force F of magnitude 18 Newton. Use G is equal to 10 meters per second squared. The question is, determine for each force the algebraic values of its component vectors along x-axis and y-axis. First, what are the forces acting on the chariot? The forces are the weight, normal reaction of support, the friction, and the pulling force F. To find the components, we should start first with indicating the positive direction of motion, which is going to be the x-axis, and y-axis is taken to be perpendicular to the x-axis. The direction of the normal reaction of support is with the positive direction of the y-axis. Then N has only one component, which is Nyj. It is equal to 150J in a Newton. Nx is equal to 0 and Ny is equal to 150 Newton. The direction of the weight is opposite to the y-axis. Then mg, which is equal to w, wx plus wy, is equal to 0i plus minus mgj. We have to calculate here the weight using mass times gravity, which is equal to minus 15 times 10j, which is equal to minus 150j. Therefore, the x component of the weight is equal to 0 and the y component, wy, is equal to minus 150 Newton. The friction force has a direction which is opposite to the x-axis. Then F is equal to Fxi, which is equal to minus 20i. Fx is equal to minus 20 Newton and Fy is equal to 0 Newton. To determine the components of F, let's make a small diagram for F only. The pulling force F is oblique force where it has two components. It is written as F is equal to Fxi plus Fyj. To find the x component, we have to find the projection on the x-axis. Since Fx has the same direction as the x-axis, then Fx is equal to plus F cosine alpha, which is equal to 80 cosine 50, equal to 51.42 Newton. To find the y component, we have to find the projection of F on y-axis, and since it has the positive direction of the y-axis, then Fy is equal to F sine alpha, which is equal to 61.28 Newton. Now let's see how to project the weight force. Weight vector will be resolved into two components of force, one directed parallel to the inclined surface and the other directed perpendicular to the inclined surface. Let us see how. Note that in physics, a tilted surface is called an inclined plane. Consider a box moving upward on an inclined plane, which is the line of the greatest slope that makes an angle alpha with the horizontal. The force of gravity or weight is always directed vertically downward, which means it is perpendicular to the horizontal line of smallest slope. To make projections, first we should draw the x and y axes. X-axis, as you can see in the figure, should be drawn parallel to the inclined plane, which will represent the path followed by the particle or the studied system. Y-axis is perpendicular to the x-axis. Now we draw the projections, which are wy and Wx along the x and the y axes. The vector is written as W is equal to Wx plus Wy, which is equal to Wxi plus Wyj. How can we find the components? We should know an angle formed between the force and one of the axes. Here we remember from math that if two right-angled triangles have common angle other than 90 degrees, then the triangles are similar, and therefore the third angle of the first is equal to that of the other. Therefore, we can conclude that the angle that the weight makes with the y-axis is equal to alpha, which is equal to the angle of inclination. Now, alpha is opposite to Wx, and Wx has a direction which is opposite to the x-axis during the upward motion. Therefore, Wx is written as minus W sine alpha I. What about Wy? Wy is opposite to the y-axis and it is adjacent to alpha, then it is written as minus W cosine alpha j. During the downward motion, the x-axis is taken to be downward. W is equal to W sine alpha I plus minus W cosine alpha j. Notice here that Wx is positive since it has the same direction as the positive x-axis, and Wy is negative since it has the opposite direction of the y-axis. Let us solve now application number 2. Consider a block of mass m is equal to 10 kilograms moving downward an inclined plane, making an angle alpha is equal to 30 degrees with the horizontal. The block is affected by a force of a friction considered constant with magnitude F is equal to 13 Newton. Take G is equal to 10 meter per second squared. Question 1. Name the forces acting on the block. The forces are the weight, which is vertically downward, the normal reaction of support, which is perpendicular to the inclined plane, and the friction F, which is opposite to the direction of motion. Part 2. Determine the components of the weight and verify that its magnitude is 100 Newton. The projection of W shows that W is equal to mg sine alpha I minus mg cosine alpha j. By calculation, we find that W is equal to 50I minus 86.6 j, therefore its magnitude is equal to 100 Newton. Now let's define external and internal forces. External forces are forces caused by external agent outside the system. Internal forces are forces exchanged by the objects in the system. To determine what force should be considered external and internal, mechanical system should be clearly defined. But how does the selection of a system affect the force that we need to consider? To understand the concept and the difference between internal and external forces, we give the following example. 3 blocks 1, 2, and 3 are moving together under the action of an external force on a smooth plane. Remember that the smooth surface means that friction is equal to 0. What are the forces acting on each of these blocks? Note that the symbol F1 on 2 means that the force is exerted by 1 on 2. Each block exerts a force on the block just beside it. For example, block 1 exerts a force on block 2, which is called F1 on 2. At the same time, the block 2 exerts a force on block 1, which is called F2 on 1. And in the same manner, the forces of interaction between blocks 1 and 2 and 3 are drawn. We don't forget also the weight, the normal reaction of support for each block. After listing all the forces acting on the blocks, what happens if we take the blocks 1 and 2 as one system? We name this system System A. The forces F1 on 2 and F2 on 1 are called internal forces since they are exerted by one block on another in the same system. So the external forces acting on this system are weight 1, normal 1, weight 2, normal 2, the force exerted by the block 3 on block 2, and the external force. Now, if we take the system to be only block 2, the external forces are W2 and 2, F3 on 2, and F1 on 2. Here, all the forces acting on block 2 are considered to be external. In describing the motion of a moving object, thanks to Newton's laws, which relate an object's motion to the forces acting on it. What are Newton's laws of motion? First law, which is the law of inertia. An object at rest remains at rest. and an object in motion remains in motion unless an unbalanced force acts on it. Its form is sum of the external forces is equal to 0. The second law, or the fundamental principle of dynamics. The acceleration is directly proportional to the net force applied and inversely proportional to the mass of the object. Its law is written as sum of the external forces is equal to m times a. Third law, which is the law of interaction. To every action, there is a simultaneous reaction, equal in magnitude and opposite in direction, and it is written as F A exerted on B is equal to minus F B exerted on A. In the upcoming videos, we are going to discuss these three laws of motion. Let's now sum up. F can be written as F1 cosine alpha I plus F1 sine alpha j. Weight can be written as plus or minus W sine alpha I plus minus W cosine alpha j. And external forces are forces caused by external agent outside the system. Internal forces are forces exchanged by the objects in the system. Thank you for watching.